आपने पढ़ा तो है ना क्रोमेटोग्राफी, यू हैव स्टडीड क्रोमेटोग्राफी राइट? Students, haven't you studied chromatography in
Yes,
your
ma'am.
previous?
Yes, ma'am.
Okay, तो आपने वहाँ पे क्या पढ़ा था?
Retardation factor.
Retardation factor, okay, that comes बाद में. अभी हम रिटार्डेशन फैक्टर की बात नहीं कर रहे हैं, अभी हम लोग किसकी बात कर रहे हैं? रिटार्डेशन फैक्टर आता है, अग्रीड, बट अभी हम बात कर रहे हैं, वी आर टॉकिंग राइट नाउ इज अबाउट our mixture of sample when interacts with stationary phase and mobile phase, what happens, how the separation occurs.
If attraction toward the stationary phase is more, then it remains in the column. If it attraction more towards mobile phase, it come out from the column.
Perfect, बिल्कुल सही बोले आप. This is the basic principle. What happens is, if we have a two compound, a two material in a mixture, suppose one material has more affinity towards stationary phase, it will retain in the stationary phase and it will move ahead against the gravity a little slower than the one which has higher affinity towards mobile phase. Did you follow me?
Yes, ma'am.
Yes. So the basic principle is the affinity towards stationary phase or mobile phase decides the separation. Okay, now in chromatography we have different types of chromatography. We have partition chromatography, we have adsorption chromatography, we have size exclusion chromatography, we have ion exchange chromatography. So this you will learn in your coming theory classes, because we have an exclusively a unit for chromatography. In that everything is included. Right now we are only focusing on TLC, that is thin layer chromatography. Now this thin layer chromatography is a two-dimensional chromatography. So you might have performed a practical on paper chromatography in your graduation. I believe you have done that. You did your paper chromatography or TLC, which you have performed?
TLC.
अच्छा, you have performed TLC. अच्छा बताइए, what you have done in your TLC practical. Tell me what was your stationary phase. Tell me what kind of mobile phase you have chosen. You have performed TLC, so it is not a new thing for you.
Silica gel with thin plates. We are stationary phase.
Okay, good. स्टेशनरी फेज आपका सिलिका जेल था, तो आपने जो स्टेशनरी फेज लिया था, was it a aluminium sheet or was it a glass slide on which you poured a silica gel and made a uniform?
Aluminum sheet.
Okay, fine. You did with aluminium sheet. Actually, in previously, before this aluminium sheet was available, like in the market, at that time, a glass slide was used. A glass slide. You understand what is glass slide, right? A glass slide was used, and on that glass slide, silica gel was made. A proper uniform silica gel was made, and that was poured onto the glass slide, and it was made uniform, and then it was allowed to get heated at particular temperature so that it gets fixed on that. So that was used as stationary phase in earlier times, but right now we have an easy access with aluminium sheets, so we don't have to prepare that. No, in nowadays also people are preparing, because while they have to monitor some reactions, what monitor some organic reaction, it is not feasible every time we go and cut a plate of aluminium sheet and we spot our mixture there. So for that purpose, people nowadays also use that glass slide with silica gel on that. But however, in your practical, you will be, I mean, if you were there in the practical sessions, you might have got this aluminum sheets. So right now we are talking about stationary phase. Now tell me, stationary phase is TLC the stationary phase in TLC is polar or non-polar, and how do you understand what is polar and non-polar?
Yes, ma'am. Water likely means polar solvent, and water not likely means non-polar solvent.
अब वाटर नॉट लाइकली मेरे को समझ में नहीं आता, थोड़ा सा इलैबोरेट कर सकते हो?
Hydrophobic map.
Okay, fine. Hydrophobic. Okay, fine. But can you please tell me, uh, what exactly polar molecules or polar solvent mean? Yes, yes, Ms. Richa.
Ma'am, polar solvent means it is able to form a hydrogen bond.
Okay.
And it locks
So
up.
how will you define? Okay, fine. Okay, continue, Richa. Continue. Sorry.
Done, ma'am.
Can let me tell you that you all agree with that water is a polar solvent, right? You all agree with me?
Yes, ma'am.
Yes, ma'am.
Fine. Why it is known as polar solvent? There will
Because
be
it's have
one.
positive and negative radicals. Because polar solvents have a positive pole and negative pole both. So we call that polar solvents.
Okay, fine. So is this, see, those have positive sides and negative, I mean, those have positive charge and negative charge. I agree with that. But there is one thing that you people are missing.
Dipole moment.
Dipole moments,
Dipole moment.
partial charges.
Dipole moment, correct. You're going on the right track. Okay, fine. Dipole moment. Then a dipole. Why this dipole moment is, why this come into picture? Uh, I guess Nikhil is speaking something, but I cannot hear him.
Because of electronegativity.
Okay, good. You're going on the right track. Fine. Electronegativity. How electronegativity is again generated or developed?
Difference in charge.
Difference in charge. Okay. Let's dig more. Fine. Difference in charge. Aage?
Large difference between electronegativities of two elements.
Perfect. Right. You're absolutely right. But tell me why this electronegativity, large difference in electronegativity is there?
Because of tendency to attract electrons.
Fine. Okay. Let's talk more. Let's dig more. Fine. Come on. और क्या बोल सकते हो आप? Please be louder. I cannot hear you.
Atomic number and distance.
Atomic number and distance. Let's go more into electron side. Electrons. See, I've given a hint to you. Let's talk about electrons. देखो, this is sure electronegativity arises because of electrons, right? Electrons play a major role. हाँ या ना?
Yes.
Fine. तो अब आप बताइए मेरे को कि ऐसा क्या हो रहा होगा कि इलेक्ट्रोनेगेटिविटी, लार्ज इलेक्ट्रोनेगेटिविटी दिखाई पाया जाता है in polar solvents. See, when there is an
Ma'am, because
हाँ जी कहिए कहिए.
because of covalent bond is highly is tightly is more tightly added to the more electronegative element because of covalent bond, we can say it specifically.
See, you are actually going to right path, but let me give you the exact words that we use for polarity. It is, there is an unequal electrons being shared between two atoms. When there is an equal number of electrons being shared between two atoms, we say those are non-polar. And at that time, the electron negativity is not that large. Right? When there is an unequal distribution of electrons between two atoms, at that time the electronegativity comes into picture, and thus we say that those solvent have more polarity, those are highly polar. So our TLC plate, you all said that in TLC stationary phase is generally silica. So now you tell me, the silica that we use is polar or non-polar?
Polar.
It is polar, right? It is polar. So our stationary phase is polar. Now our solvents, our mobile phase, that is our solvent system, our mobile phase may be polar or non-polar or between them. So it depends on the type of mixture that we wanted to separate on that particular TLC plate. Our solvent system or mobile phase will be optimized according to our mixture, other compounds that has to be separated. Based on that, our solvent system will be optimized. Fine, it may be our mobile phase may be polar, may be non-polar. It is actually based on our mixture, what type of mixture we have to separate on our TLC plate. But however, our stationary phase is totally phase, that is polar. In TLC plate, I'm talking just for TLC. Okay, so now let us move to our practical. So we have three practicals where TLC is being used. The first one is where we separate dyes. That is, textile dyes, or at present we are talking about two dyes, colorants that we separate with our TLC using a particular solvent system. Our solvent system is priorly optimized. The solvent that we have to take, the volume is also priorly optimized. So Archana, I have got a video on TLC. So let me play that. Just give me a second. Is my screen visible to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. Just give me a moment. I haven't started the audio. Just see this video, and you will have a better idea about TLC.
Dave here. Let's get some TLC. He knows a lot about the science stuff.
Is the audio properly audible to you?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
We just learned about extraction, which is a technique we can use to separate compounds on the basis of differing solubilities. Now let's learn about another separation technique called thin layer chromatography, or TLC for short. This separates compounds on the basis of differing polarity. So let's go ahead and see how this works. In order to do TLC, we will need some TLC plates. These have a thin layer of silica gel spread out on a glass surface. It will be important to understand the structure of this silicate material, as this is what will cause the components of the mixture to separate. It is a network solid of silicon dioxide with alternating silicon and oxygen atoms in every direction. And at the surface of this material, there will sit many hydroxyl groups. These, of course, are polar and can participate in dipole-dipole interactions with other polar substances. Now, in order to perform the separation, we will draw a line in pencil fairly near the bottom of this plate, right on the silica. Then we take the solution containing the components to be separated and insert a capillary tube. Some of the solution will rise up into the tube by capillary action, and we will then spot the plate with the contents of the tube. To do this, press the bottom of the tube to the plate, right on the line we drew, firmly enough that the solution gets deposited onto the plate, but not so firmly so as to disrupt the silica. Spot 2 or 3 times to load most of it on there. Then we will use some kind of solvent or solvent system to develop the plate. We will talk about solvent selection in a moment. For now, let's just refer to it as the solvent. If we place a little bit of the solvent at the bottom of a beaker or developing chamber, we can then place our spotted TLC plate in the beaker, leaning against the side. The line with the spot must sit above the solvent and not be submerged in the solvent, or our sample will wash away. So make sure the pencil line is high enough and the solvent is low enough that the spot sits slightly above. Now cover the beaker with something so that solvent will not evaporate, and we can watch the plate develop. The solvent, which we call the mobile phase, will begin to rise up the plate, which we call the stationary phase. It does this by capillary action, just like we saw with the capillary tubes. And once it hits the sample, it will drag those components up with it. However, as the components move across the plate, they will interact with the hydroxyl groups in the silica to differing degrees. A substance that has polar functional groups, or a strong net dipole, will interact significantly with the stationary phase. We can say that this substance is strongly adsorbed to the stationary phase. This will cause it to move more slowly along the plate, almost as though the interactions make it sticky. A substance that is largely nonpolar will not interact very well with the stationary phase, and will instead move along the plate very close to the solvent front. We can say that this substance is weakly adsorbed to the stationary phase. Once the solvent is rather close to the top of the plate, but making sure not to let the solvent reach the edge, we remove the plate and quickly use a pencil to mark the solvent line, as this will not be visible in a few moments. Then we let the plate dry. Now it's time to see how far each component traveled. It is possible that the components are visible, but this is typically not the case, so we usually have to use a special technique to see where they are on the developed plate. Often we use UV light, as certain functional groups in organic molecules will interact with these wavelengths and glow under this light. If using these, be extremely careful not to look directly at the light source, as this can seriously damage your eyes. Because of this, visualization is typically done either in a special box or by using handheld lamps to point the light downward, while using protective glasses as a precaution. With the plate under the light, use a pencil to trace anything you see for later analysis. Ideally, there are circular dots, but there may also be lines, streaks, or splotches. just trace precisely what's there. Instead of UV light, sometimes we will have to use some kind of staining agent, like iodine, anisaldehyde, or others. These each react with a particular type of functional group and will cause the spots to become visible. So we just use some tweezers to dip the plate in there, wash it off, and put it on a hot plate until the spots show up. And then we have visual data to work with. Now we can assign a retention factor, or RF value, to any dot on the plate. This represents the distance traveled by a particular substance as a fraction of the distance traveled by the solvent front. To get this, we just measure the distance from the line where spotting took place to the center of the dot and divide that by the distance from that same line to the line at the top where the solvent front ended up. This is why we do not let the solvent reach the end of the plate. Otherwise, we could not get this second value, and we could not calculate RF values. We will get some value between 0 and 1, and we will do this for any spot on the plate. If we actually intended to physically separate the mixture to collect its components, we can remove the region of the gel each compound sits on and then perform an appropriate extraction. But typically, TLC is used as an analytical technique. We can use TLC to monitor a reaction. Say we are performing a reaction where the reactant and product have significantly differing polarities. If we spot a plate with the solution in the reaction flask before adding any reagents, we can get the RF for the reactant. Then, once the reaction has proceeded for some time, we can spot another plate and develop it. If we get that same spot again, along with a new spot that has a totally different RF, we will know that some product has formed, but some reactant still remains. If we wait a bit longer and do it again, and this time only the new spot shows up and not the first one, we know that the reactant is gone and the reaction is complete. Another reason we would use TLC is to select a solvent system for column chromatography, which is a large-scale separation technique. We will want to find a solvent system that maximizes the distance between two components on a developed plate, because that will best enable us to separate them in a column, which we will learn about in the next tutorial. This solvent system is typically a mixture of two or more solvents, like hexanes, ether, ethyl acetate, or dichloromethane. We may have to mix hexanes and ethyl acetate in a 1-to-1 ratio, or 2-to-1, or 5-to-1. It's usually difficult to predict what will work best, so just try something and see what happens. If the two components end up very close together on the developed plate, this was a bad choice, as they didn't separate well. If they separate a bit but end up towards the bottom of the plate, this is also bad, as it means they travel very slowly across the stationary phase, and it will be a pain to collect them. The ideal solvent system will result in something like this, where the two components are separated very well, one of them towards the top of the plate and the other more near the middle. This solvent system will be ideal for column chromatography, which is the technique that we will use to actually physically separate all of the contents of our reaction flask, once the reaction is complete and the organic products have been extracted. This is an extremely important technique for any organic chemist, so let's move forward and learn about that next. Thanks for watching, guys. Subscribe to my channel.
So I guess you have got some idea about how TLC works, what are its components, but let's watch one more a small video where you will have a better understanding about TLC. So may I please ask Archana to play that video? Please hold on, I'm doing.
TLC is a chromatography technique used to separate non-volatile mixtures. As well as other forms of chromatography, in TLC there is a mobile phase, which may consist of a solvent or solvent mixture. And there is a stationary phase, which is a plate that coated with a thin layer of adsorbent material, usually silica gel, aluminium oxide, or cellulose. To run a thin layer chromatography plate, a pencil line is drawn, about 1.5 centimeters from the bottom edge. Also, the plate can be labeled using a
Archana, please
pencil
pause
to
the
show
video.
the origin of the
Pause the
drop.
video.
Thin layer chromatography can be used to identify.
See, now this is, you can see, this is a stationary phase plate, that is TLC plate, where silica gel has been coated. Now before we actually place our spots, how do we do that? So in our plate, जहाँ से हमें start करना है, तो अब at least 1 centimeter above we have to just draw a line where you can see that the cursor is being there. We have to actually draw a line with pencil, and then number of samples, number of mixtures we have. If suppose we have one mixture that contains 3 samples, then we will have 4 spots that we have there we can see we have four spots. That means we have 3 mixture, we have 3 sample and one mixture containing 3 samples. You can see there are 4 dots. So we are doing this so that जब हम spot रखेंगे, we have a better knowledge कि where we have to keep our spot, and सारे के सारे spot will be in uniform line, that means in uniform, at uniform space. समझ में आ रहा है आपको? distance ऐसा ना हो कि कुछ ऊपर नीचे चला जाए. So for that we are actually placing a uniform straight line जहाँ पे we are actually putting some dots, so that हमें पता चलेगा कि अच्छा ये वाले डॉट पे we have to place this sample, so that कुछ भी ऊपर नीचे ना जाए. समझ में आ रहा है आप लोगों को? Okay, well, let's continue with our video, Archana.
Compounds present in a given sample mixture. A small drop of the mixture is placed on the baseline of the thin layer plate. And similar small spots of known compounds are placed alongside it.
Archana,
When
please pause the video. So देखो, in this you can see that the first spot was of a mixture, the second spot was of compound A, the third was of compound B, and fourth was of compound C. ठीक है, इतना आपको समझ में आ गया कि आपने देखा ये क्या हो रहा है. So we are actually using a capillary tube, and a capillary tube should be such that it should have very narrow end. बहुत ही पतला सा ओपनिंग होना चाहिए, बहुत ही छोटा सा ओपनिंग होना चाहिए. Otherwise, see, I guess people can see me, right? Yeah, fine. See, जो भी हमारा ओपनिंग होना चाहिए ना कैपिलरी ट्यूब का, दिख रहा है आपको पेन? Yes. Just give me a moment. So you can see my pen snib. इसका जो पॉइंट दिख रहा है आपको, इससे भी छोटा ओपनिंग होना चाहिए. हमारे जो पेन है ना, हमारा जो पेन होता है उस पेन का जो एक्चुअली पॉइंट होता है उससे भी छोटा ओपनिंग होना चाहिए कैपिलरी ट्यूब का. द रीजन इज जैसे वी स्पॉट आर, सपोज जैसे द वे वी स्पॉट आर, am I clear and audible to everyone?
Yes, ma'am.
मैम वॉइस इज क्लियर बट साइड में नेट कनेक्टिविटी इशू के लिए जो होल्डिंग का नॉइज आता है ना वैसा आ रहा है सर.
मेरा नेट तो फुल दिख रहा है और मुझे यहाँ पे कुछ ऐसे आ नहीं रहा कि मेरा नेट में कोई इशू है.
नाव नहीं आ रहा, अब नहीं आ रहा.
Okay, fine. See, suppose this is my, तो I just have to just एक simply ऐसे touch करके ले लो. Otherwise क्या होगा ना, what happens is the way if we actually put our, if we actually keep our capillaries, just to imagine that, just think that this is a capillary tube and we have a very small opening of this capillary tube. Now we'll just place a spot over here, but we have to make sure that we are just keeping a very small spot. Otherwise what happens is जैसे ही आप spot डालोगे ना, तो it will start spreading. You have seen that जैसे ही हम ink को कोई ink जो है ना, ink उसको जैसे ही हम कहीं पे डालते हैं तो कैसे वो spread हो जाता है, तो वैसे स्प्रेडिंग नहीं होना चाहिए. तो वी शुड मेक श्योर दैट द वे वी स्पॉट with a capillary tube, it should be, our spot should be very small. तो फॉर दैट पर्पस हम लोग क्या कर रहे हैं, हम लोग एक लाइन ड्रॉ कर रहे हैं एंड उस लाइन पे हम स्पॉट डॉट्स डाल रहे हैं. तो उस डॉट पे ही मेरे को अपना सैंपल स्पॉट करना है. समझ में आ रहा है आप लोगों को? अगर क्यों स्ट्रेट लाइन ड्रॉ करने का दूसरा रीजन ये है कि मैंने स्ट्रेट लाइन ड्रॉ किया, मैंने स्पॉट डाला, एक स्पॉट मैंने यहाँ डाला और दूसरा स्पॉट शायद से मेरा थोड़ा सा ऊपर चला जाएगा. तो क्या वो जो सेपरेशन जब होना होगा ना, तो वी विल गेट अ डिफरेंट आरएफ वैल्यू. मतलब जो RF value exactly we should get, that we will not get. There will be slight difference in our RF value. So that is the main purpose of drawing a straight line and keeping the dots. Even if we don't keep a spot dots, it's okay. अगर हमें पता चलता है dots इसलिए, so that between two spots we will have a same space, like दो तीन, अगर we have 4 compounds, 4 spots, तो हर दो spot के बीच में we will have same distance. So when it will actually move ahead against the gravity, जब वो ऊपर जाएगा तब वो ऐसे, वो उसको जाना चाहिए ऐसे जाना चाहिए, स्ट्रेट जाना चाहिए. However, कभी अगर स्पॉट मेरे पास में दो स्पॉट के बीच में बहुत कम डिस्टेंस आया, at that time what will happen, दोनों साथ में जाएगा and then it will sometimes will mix up. So these are some limitations and drawbacks. So for that purpose, to overcome that, we were using some techniques like straight line draw karo, please keep a dot so that both spots will have some distance between them. So when they move ahead against the gravity, we can have a proper bands visible over there once the TLC run is finished. So let me ask Archana to continue with that video. Is it possible for you, Archana?
Yes, it is. I'll just.
Yes, please and please.
TLC plate is then placed in the chamber so that the spots do not touch the surface of the eluent in the chamber, and the lid is closed. The solvent moves up the plate by capillary action, the sample mixture, and carries it up the plate. The separation is based on differential partitioning of the sample components between the mobile phase and the stationary phase. The component which has less affinity to the stationary phase, consequently, less interaction, travels further up the TLC plate. And the component which has more affinity to the stationary phase, consequently, more interaction, travels slower on the plate. This separation can be carried out according to the nature of the mobile phase, which is nonpolar, and to the TLC plate type, which is generally a polar stationary phase. In this case, this
Yes, Anar. Yes, Anarga.
It's okay. I just wanted to explain that portion where we can see the chamber.
Did you ask me
Solvent
to
chamber.
pause? Did you ask?
Yes, I did. Okay. See, you are seeing the solvent chamber over there, right? So we have to keep our TLC plate, once the spots are being spotted, we have to dry that spots. अब spots भी कैसे कि भैया मैंने एक डाला मैंने निकाल लिया, just डाला निकाला, फिर दूसरा डाला, तीसरा डाला, चौथा डाला and निकाल दिया, ठीक है. Now once we have spotted our samples in our TLC plate, we have to respot so that in case sufficient amount is not being spotted, then it will not show the run. For that, what we'll do is, for that normally what we do is, अर्चना तू प्लीज म्यूट कर देना यार खुद oh good okay fine हाँ मैं see somebody's background noise is coming.
Is it still mine?
Okay. No, it's not yours. Somebody else's. Somebody has unmuted them. अरे भैया please कर दो यार. Okay, fine. Let me explain it. So you can see the solvent chamber over here. तो हमें क्या करना है? We have to place one spot. Onto that, we have to again put another spot so that the concentration or the amount of sample is sufficient enough so that it can show a proper run. So for that purpose, we have to put a two spot. However, the spot should be such that those spots are very, very, very small. Otherwise, it will show a, I had already explained to you the way ink spreads. In that way, the spots also spreads. So for that purpose, we have to make sure the spots are very small. And दूसरी एक बात ये है कि when we keep that TLC plate, once it has been spotted and it has been air dried, the spots are being air dried, what we'll do is we'll actually hold that TLC plate from the upper side. आप लोगों को समझ में आ रहा है कि what am I trying to explain it to you?
Yes, ma'am.
Ma'am, your voice is not audible properly.
My voice is not clear.
Background voice is coming from, I don't know where are you, but background voice is very high.
सब लोग को मेरा बैकग्राउंड वॉइस आ रहा है बैकग्राउंड नॉइज आ रहा है
Yeah, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Anarga, try turning off. Then you try.
सॉरी क्या बोल रही है
वीडियो ऑफ करके फिर ट्राई कर
हाँ ओके फाइन हाँ अभी आ रहा है क्या
No, ma'am.
ओ गुड चलो लेट्स स्टार्ट देखो इसमें आप लोगों को वी कैन क्लियरली सी दैट कि the TLC plate has been kept into a solvent chamber where we have some mobile phase. The TLC plate should be held from upside जहाँ पे polar लिखा हुआ है ना यहाँ पे दिख रहा है आप लोगों को polar लिखा हुआ from that area we have to मतलब TLC plate के ऊपर where the silica gel जहाँ पे अर्चना please show them कि silica gel कहाँ पे डाला है तो silica gel जहाँ पे है ना वहाँ पे हमने touch नहीं करना है where we have to touch is the ends of TLC plate exactly जहाँ पे cursor है ना वहां से we have to hold a TLC plate. We should not place our finger or we should not touch on the silica gel. We should not touch. So we have to hold that TLC plate from the ends and then we have to keep it into a solvent chamber such that जो spots हमने नीचे डाला है ना that spot should not get immersed into our solvent. It should be above the solvent. जो भी our solvent is there, it should be the solvent should be such that the volume of the solvent should be such that, or the spot should be placed in such a position that the spots are not being immersed in that solvent or in that mobile phase. जो भी spots डालना है ना वो मोबाइल फेस के अंदर डिप ना हो इतना याद रखना स्पॉट्स हमेशा जो है मोबाइल फेस के ऊपर ही होना चाहिए एंड द अदर थिंग इज कि हमने ऊपर भी अबव जो ऊपर का एरिया है ना जहाँ पोलर लिखा है जहाँ द टीएलसी प्लेट एंड्स उसके भी एटलीस्ट एटलीस्ट 1 सेंटीमीटर, उसकी जस्ट 1 सेंटीमीटर जितना डिस्टेंस था वहां पे वी हैव टू अगेन ड्रॉ अ स्ट्रेट लाइन सो दैट वी कैन हैव अ लिटिल नॉलेज कि हमने सॉल्वेंट कहाँ तक रन करना है. You understand? We have to draw a straight line. We have to draw a straight line just 1 centimeter below where the TLC plate ends. जहाँ से TLC plate end होता है ना उसके नीचे 1 centimeter जितने distance पे we have to again draw a straight line so that when the solvent reaches that straight line we will get a simple we will have an idea कि हाँ भैया our run has been complete. We have to just run till there. Otherwise, what will happen is the solvent will go beyond the plate. पूरे प्लेट के ऊपर पूरा ऊपर चढ़ जाएगा. जैसे ही वो होगा, जैसे ही that will happen, our spots will also go ahead. Then we have to find that RF value we will not get because we didn't know what distance our solvent traveled because the solvent has been traveled beyond our plate. Did you understand?
Yes, ma'am.
Okay, now the solvent system, जो solvent chamber है, this chamber, normally हम lab में क्या करते हैं, ये तो काफी लंबा square well है, and we have a proper lid. Otherwise, in our lab, because we cannot provide these many square wells to everyone, and because ये जो plate है, this is bit wider one. हमने जो use करना है, that is a normal narrow small plate. So we use a glass beaker, and then we use a watch glass to cover it up. Now, while we make a solvent system in a solvent chamber, we actually pre-saturate it. Pre-saturation means we actually prepare a solvent system and then we allow it to get saturated by closing it with a watch glass. That means कि अंदर का जो solvent है, the solvent that we have in our glass beaker does not get evaporated. For that purpose, we are closing it with a glass beaker. We close it with a glass beaker so that उसके vapors अंदर ही अंदर रहे. We are pre-saturating our solvent chamber. We use the word pre-saturation. The reason behind pre-saturating our solvent system is that when we place our TLC plate into that chamber, we should have मेरे इंटरनेट इश्यूज है.
नहीं मेरा है, मेरे यहाँ पे प्रॉब्लम.
Okay. The reason behind pre-saturation is that the TLC plate does not get dry. For that purpose, we are actually pre-saturating. If the TLC plates gets dry inside our solvent chamber, then we'll not get a proper separation of our peaks. Is that clear to everyone, or do you want me to explain it again?
Okay.
मुझे आप लोगों का वॉइस क्लियर आई है. Somebody मेरा ही वॉइस का वापस रिपीटेशन आ रहा है. Is this background noise from my side? अर्चना, ये बैकग्राउंड नॉइस किस जगह से आ रहा है? मेरे यहाँ से आ रहा है.
पता नहीं कहाँ से है. देखो मेरा मैं जब म्यूट रखती हूँ तब भी है.
हाँ, तब भी है.
स्टूडेंट्स में से किसी का है क्या?
वही स्टूडेंट्स अगर किसी ने अपने आप को अनम्यूट कर दिया तो प्लीज म्यूट योरसेल्फ बिकॉज दैट्स डिस्टरबेंस.
मैम सिर्फ आपका ही अनम्यूट है, सबका म्यूट ही है.
अच्छा, somebody was saying something. क्लियर है
मैम
सब लोग? क्लियर हुआ?
हेलो मैम,
मैम रिपीट कर.
सिर्फ आपका ही
हाँ.
अनम्यूट है. और बैकग्राउंड आप अगर हेडफोन यूज करते हो तो वो रिमूव करके अगर बोलेंगे तो शायद ये
ओके,
इशू.
मैं कोई हेडफोन यूज नहीं कर रहा. I'm not using any headphone, nothing at all. यहाँ कोई ऐसे नॉइज है नहीं, बैकग्राउंड नॉइज है नहीं. चलो लेट्स कंटिन्यू. सो डिड यू अंडरस्टैंड व्हाट आई वाज ट्राइंग टू एक्सप्लेन टू यू पीपल?
यस मैम.
Fine. Let us continue with our video. Let me unmute myself so that we can know whether it is coming from my side or not. Archana, please continue.
In this case, this method separates analytes based on their affinity for a polar stationary surface, such as silica gel. The more polar the analytes are, the more retained they will be on the stationary phase. The more hydrophobic they are, the more they will prefer the mobile phase, and as a consequence, they will move higher up the plate. The solvent is allowed to rise until it almost reaches the top of the plate. That will give the maximum separation of the components. The plate should be removed from the chamber before the solvent front reaches the top of the stationary phase. Then this front is marked. The plate can be dried in ambient air or under the warm air of a dryer. The plate is visualized under the UV lamp or by using certain chemical reagents if the substances of interest are colorless. Some plates are pre-coated with a phosphor, allowing many compounds to be visualized by using ultraviolet light. Or a derivatization of the sample with fluorescent reagent can be carried out before running the TLC plate. As soon as the UV source is switched off, the spots will disappear again. Therefore, the positions of the spots should be marked by drawing a pencil circle around them. And the retention factor of each component is determined. For chemical visualization of stains, various visualizing agents react with the spots to produce visible results, such as iodine, ninhydrin, potassium permanganate, and vanillin. The plate can be immersed in these chemicals, or sprayed. Once visible, the RF value, or retention factor, of each spot can be determined by dividing the distance the compound traveled by the distance the solvent front traveled, using the initial spotting site as reference. A compound with a lower RF tends to have more polar functional groups than a compound with a higher RF. Based on the RF values, compound A is the most polar, and compound C is the least polar. The retention factor of the spots in the mixture is determined and compared with those of the known compounds. In this, we found presence of the compound A and the compound C.
I don't know from where this voice is coming. Okay. Now, am I clearly audible?
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
You have okay, fine. You have seen that they actually took the TLC plate just above 1 centimeter below the TLC plate ends, and then they actually drawn a straight line. However, in our case, what we do is we priorly do that because we do not wait. We does not wait to see that, because from we have to see it from naked eye that whether the it has actually reached 1 centimeter below our TLC plate or not. So what we do is we initially priorly we before we start our run, we priorly make a draw a straight line. You can see where the cursor is moving, and then we place it in TLC chamber and we allow it to run. the similar way that has been shown here in this video will allow it to run. It may take 10 minutes, it may take 15 minutes, it may take half an hour, it may take 45 minutes, depending upon the solvent that we have used, mobile phase that we have used. Depending upon that, depending upon that, the separation occurs or the run finishes depending upon the mobile phase. If the mobile phase is totally non-polar, it takes large amount of time, huge amount of time to complete the run. If it has a moderate polarity one, so it finishes. It does not take huge time. If it is very much polar, it runs very fast. So here with the RF value, we can conclude that the RF value which has the one which has higher RF value has very low polarity. That means it actually goes with our solvent system. It moves with our solvent system. The one which have medium, I mean the RF value in between 0 and 1, just in between 0 and 1, will have medium polarity, and the one which have very less RF value, that is between 0 and 1, which have very less RF value, is of higher polarity, which indicates that it is more retained by stationary phase than of mobile phase. You understand? Students, did you follow that?
Yes, ma'am.
Okay. So with this is something very briefly explained to you how we deal with TLC. What are the components that being used? One is solvent chamber. See, suppose you are asked, please tell us about the components that we use in TLC. So you can tell that TLC plate, solvent chamber, a capillary tube, samples. So these are the components, right? Now let us move ahead with our practicals, which is separation of dyes on TLC plate. So Archana, may I please ask you to show the PDF files, the PDF file, journals PDF. Can is it visible? Archana, I cannot hear you.
Is it visible?
Yeah, it is visible, but please share that scanned journal.
Okay, okay, please. Is it visible now?
Oh, yes, yes, it is. So we will be separating. I mean, we are. If you were in lab, you might have separated these dyes. However, we do not have that access. Let us see it. How do we do that? So we are using a TLC plate to separate two dyes, that is rhodamine B and fluorescein. So both these dyes, rhodamine B is reddish in color, and fluorescent is fluorescent color. It is actually a yellowish color. You know what is fluorescent color is. Same that color. So here in this we are using a solvent system, that is acetone and water in the ratio of 3:3. Now this solvent system is actually an optimized solvent system. So you know it takes very trial and error. On trial and error basis, the solvent system has been optimized. So the solvent system is acetone is to water, that is 3:3, both 3 ml 3 ml. We will be taking 3 ml of acetone, 3 ml of water in a glass beaker of 250 ml, and then 250 ml or 150 ml. Then we will be closing that beaker with a watch glass to pre-saturate our chamber. and then 1% of dye solutions are prepared. 1% dye solution is being prepared, and from that dye solution with capillary tube we will be, अर्चना ऊपर लेके जाना, just go और ऊपर जान दे, वो एक ड्रॉ किया हुआ है ना प्लेट, हाँ 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 हाँ, ऊपर जान दे, ऊपर जान दे, या गुड गुड, बस यहीं पे यहीं पे यहीं पे. तो जहाँ पे you can see we have drawn a straight line, and that straight line we have placed 3 dots, and above in the upper portion also you can see there is a straight line. So we will be actually placing three spots, one of fluorescent that is being tagged as F, one of rhodamine B that is being tagged as R. So pehle we will be placing fluorescent F. Either you can place either R or F, it depends on your wish. ये तो just उस time पे किया हुआ है, that is shown over here. So when we place fluorescent, तो जहाँ पे F है, where it has been standard F, so where there we are placing a spot, and again we will be placing a spot in the mixture area, that is F plus R. एक बार spot हो गया, now we'll go with rhodamine. So rhodamine का capillary, there will be a particular capillary for rhodamine. Again we'll be taking rhodamine, we'll be spotting rhodamine, and then again that rhodamine sample will be spotted in the mixture. This we are doing it for the first time. अगर we see that अच्छा ठीक है, मेरे को लगता है कि the proper, I do not see the proper consonant, though because here it is dye, it is okay with one spot. Otherwise, if it is some dyes or amino acids or some other molecule which is colorless, and we see that the concentration is not that more to have a good run or good separation, we'll spot another, we will give another spot in that place. So इसमें क्योंकि ये डाइज है तो एक ही बार करना है, क्योंकि ये डाइज है. अब the reason that we are using standards माने pure fluorescent and pure rhodamine. The reason we are using pure fluorescent and pure rhodamine is that when in the mixture it will show a run, when in the mixture when it runs and then show a separation, to understand where our exact spot is, what the separation, once it has been separated, you can see we have 2 spots after separation. So we have to know which spot, which separated mixture is for what. For that we are using standards. See, you can see on the left side fluorescent has been spotted and it has been separated somewhere. I mean, you can see it's run. Rhodamine ka bhi you can see a spot. अर्चना शेयरिंग चला गया. हाँ ठीक है. हियर अच्छा स्टैंडर्ड फ्लोरेसेंट के स्पॉट, हाँ हाँ दिख रहा है, गुड गुड दिख रहा है. स्टैंडर्ड फ्लोरेसेंट पे लेके जाना, स्पॉट जो सेपरेटेड है ऊपर जो रन हुआ है वो दिखा ना. हाँ, देयर यू कैन सी दैट इज फॉर स्टैंडर्ड. मिक्सचर में फ्लोरेसेंट दिखा, मिक्सचर में यस. अभी ये देखो ये ऊपर नीचे हो गया है, बट हाउएवर इन एक्चुअल केस इट इज नॉट लाइक दैट. तो here with standard we can know the separated mixture is for what component. समझ में आया. यहाँ पे F plus R we have spotted together and then it runs. After the run is completed, we can see a separation of mixture, and in that separation we can actually know कि which component is for what by comparing it with our standards. So here standard is fluorescent and rhodamine. So दोनों का when we spot a standard, after it's run, when the separation is done, we can know कि हाँ भैया ये fluorescent का है, because we can see the fluorescent standard has completed its run somewhere near to the distance that has been traveled in the mixture. Similarly for rhodamine. ये समझ में आ रहा है आप लोगों को why we are using standards?
यस मैम.
नहीं मैम, एक बार समझाओ ना बस.
Okay, fine. ठीक है, देखो आप लोगों को दिख रहा है कि यहाँ पे एक स्टैंडर्ड का भी स्पॉट लगाया हुआ है नीचे. बिफोर आर रन स्टैंडर्ड का स्पॉट लगाया हुआ है फ्लोरेसेंट एंड रोडामाइन का. You can see that. In mixture also you can see that we have spotted fluorescent and rhodamine. ठीक है. Once we allow our TLC to run, TLC को spot किया, we have kept it for drying for few seconds. It is being dried. Now we are taking our TLC, holding it from upper side on the ends without touching the plate, without touching the silica gel. We are using that plate and by holding it from the ends, we are placing it in our solvent chamber such that ये जो line आपको दिख रहा है जहाँ पे we have spotted is not being immersed in our solvent system. In such a way it is being placed in our solvent system, and then we close our solvent chamber with a watch glass, and we allow it for a run. Suppose it takes about 20 minutes to complete the run. To complete the run माने the line that we have drawn above, if the solvent system reaches that line, that means we have completed our run. Okay, so once the solvent system reaches there, we have to take out our TLC plate from the system solvent chamber. We have to allow it to dry because we now knew, and it is very much visible. It is very much visible from our naked eye that it is very much visible with our naked eye that the separation is completed, because we can see a proper separation of dyes. With naked eyes, you can definitely see that because these are dyes. One is yellow colored, that is fluorescent is yellow colored, and rhodamine is red colored. Now, in order to understand why we are using standards fluorescent and rhodamine, why can't we directly use fluorescent and rhodamine's mixture in our TLC plate? To understand that, we have to, you don't know now in mixture which is, see now this is because it is naked, we can see with naked eye, acha, we know fluorescent color is yellow, so it is for fluorescent, and the separated mixture yellow colored one is for fluorescent and the other one is for rhodamine. You can know because this is being colored. So in many cases where we use amino acids or drugs, in that case those are colorless, so you cannot know which sample is for what, right? So for that case, and in general what we do is we actually with the mixtures we spot our standards mane only pure compound. So for here in this case the pure compound is fluorescent dye and other one is rhodamine B. So we are spotting our standards also along with our mixture. Now all the three spots have almost same distance between them. The gap between two spots is almost between between, we have three spots. The gap between two spots is same gap that we have with the other one. Right? Now ये जो fluorescent spot किया है, after the run it may have went up. It shows some run, okay? So it goes up. Now after, मैं आपको बहुत ही layman language में बात कर रही हूँ, ठीक है? I'm not even using the technical terms. So I hope you're actually following me what I'm trying to say. So जैसे ही fluorescence goes up, fluorescence in the mixture will also go up. At the same distance, it will cover the same height. मैं height की बात कर रही हूँ. It will cover the same height that the height जो हमें fluorescence में दिख रहा है, the same height will be covered by the fluorescence in the mixture. Right? Am I clear to you?
Yes, ma'am.
Okay. Now when we're talking about rhodamine again in the mixture will cover the same height, same distance that of standard. जो स्टैंडर्ड जिस डिस्टेंस जिस हाइट तक रोडामाइन गया होगा स्टैंडर्ड का, उतना ही हाइट या उतना ही डिस्टेंस कवर करेगा मिक्सचर भी. सिमिलरली फ्लोरेसेंट का उतना ही डिस्टेंस कवर करेगा जितना उसका स्टैंडर्ड में है, ठीक है। इन दिस वे वी कैन एक्चुअली नो कि हाँ अच्छा ठीक है, ये मेरे मिक्सचर में इतना डिस्टेंस कवर किया, इसके सामने इसकी जैसी लेफ्ट साइड में मैंने फ्लोरेसेंस स्पॉट किया एंड राइट साइड में मैंने रोडामाइन स्पॉट किया है, तो रोडामाइन ने जितना डिस्टेंस कवर किया इन मिक्सचर आई कैन सी द सेम स्पॉट, उतना ही डिस्टेंस में आई कैन सी अ सेम स्पॉट, so that means it is for rhodamine. Whereas in case of fluorescent, it has covered, standard has covered some distance and the same distance has been covered by mixture, and now I can conclude now the fluorescence is, this is the fluorescent spot because it has also covered the same distance that of standard. समझ में आया?
Yes, ma'am.
Yes, ma'am.
Sunil.
Yes, ma'am.
Okay, good. The main purpose of spotting standards is because कि यहाँ पे in this case अगर हम standard spot नहीं करते हैं, but I know कि fluorescent का color is yellow, rhodamine का is red, because of that separation मतलब separation होने के बाद भी I can conclude हाँ yellow is this fluorescent, this much distance is it has covered, red is rhodamine, okay fine, this much distance it has covered, it is clear. However, in case of amino acids or let's say for dyes or any other compounds which is colorless, in that case it will be hard to determine that which component is what in the mixture. If we don't spot standards, then it is very difficult to understand that the spot that has been run or the separated mixture is for which component. It will be very hard to know. So for that purpose we are spotting standards. That is an ideal way. Fine. So see, we have a line drawn above, in the upper side of our TLC plate. So to that distance, we allow our solvent system to run. That is, mobile system is allowed to go till there. Once it reaches there, देखो उसके लिए you have to make sure कि हम देख रहे continuously. We are monitoring our TLC run. We are continuously monitoring. So we are allowing our mobile phase to run till that distance, and then we're taking out our TLC plate. We are actually drying it in air dry. We are allowing it to dry in the air itself. Once it has been dried, now we know what is our solvent, the distance that has been traveled by solvent, because we have already drawn a line over there. So now we have to find an RF value, that is retardation factor value. Now this value is unique, or this value is no two component will have same RF value. If two components have same RF value, it has been said that both the components are same. So you should now understand that when we are using two components, both will have different values, right? If the both samples are different, then it will have different values. So, and all the values have been reported in the literature. So now what you guys will do is, you will actually measure the distance that has been traveled by solvent. You will measure now for fluorescence. अर्चना बताना है fluorescence का distance कहाँ से कहाँ होगा, जहाँ से हमने spot किया है, fluorescence को जहाँ spot किया है और जहां हमें स्पॉट मिला है, अब कहाँ ढूंढेंगे वो चीज, हम ढूंढेंगे मिक्सचर में, वो चीज हम मिक्सचर में देखेंगे, ना कि स्टैंडर्ड में. स्टैंडर्ड तो प्योर ही है, दैट विल शो इट्स actual run. However, we are actually separating our components in a mixture. Mixture में we are showing the separation, and in that separation will actually calculate the distance of fluorescence from the initial spot to the final separation. Fine, that will be our fluorescence run, distance traveled by fluorescence. देखो आपको कर्सर प्रॉपर्ली दिखा रही है, अर्चना सब कुछ प्रॉपर्ली दिखा रही है. Now for rhodamine, similarly, so RF value will be distance traveled by our solute or the component divided by distance traveled by the solvent. ठीक है? That will be RF value, which is it will not be same with other component. वो उसका RF value unique होगा, उसका एक particular RF value होगा, and that RF value will be assigned to one molecule, one material only, one component only. समझ में आ रहा है आप लोगों को? Similarly for rhodamine की बात करें, again we'll calculate the RF value for rhodamine because it in your practical also proper separation is seen between fluorescent and rhodamine. So at that time also we'll calculate the RF value which is distance traveled by the rhodamine from the initial spot to the final separated spot. Fine, divided by the distance traveled by the solvent. That will be the rhodamine which will have a unique value. यूनिक वैल्यू का मेरा मतलब ये है कि वो जो वैल्यू है वो सिर्फ उसी के लिए ही होगा. समझ में आ रहा है? नाउ दिस यू कैन सी इट इज यस. नाउ rhodamine B जो है, rhodamine B है, for that the value is 0.629. now this 0.629 जो है ना, 0.62, let's not 9 की बात नहीं करते, 0.62, this is exclusively for rhodamine B. when we run a TLC plate with a particular solvent system that is being optimized here, which is acetone and water in the ratio of 3:3, we get a RF value of 0.62, which is exclusively rhodamine B, for rhodamine B. ठीक है, ये एक्सक्लूसिवली rhodamine B के लिए है ये वैल्यू. जब हम डाइस की बात करें, व्हेन आई गो एंड सर्च, अभी दिस यू पीपल नो कि वी हैव गिवन यू rhodamine B. ठीक है, फ्लोरेसेंस की बात करें, फॉर दैट द वैल्यू इज, अच्छा थोड़ा सा ऊपर करिए, it is 0.935. now this fluorescent value is now this RF value for fluorescence is exclusively for fluorescent. no other dye will have an RF value similar to this value. so ये now these things ये जो है ना, because you people already know, अच्छा you are being given rhodamine B or you've been given fluorescent. however, if it is not known to you which component is given to you, you just have two standards, you spotted them, you will have a separation in the mixture, and then what generally is being done is we get an RF value. Acha, I just know that these are dyes, other than that I don't know which dye these are. so what I'll do is I'll get the RF value, I'll compare the RF value with the ones that is being given in the literature. what all I know is the components that is being separated are dyes. so I'll just see in the list of dyes, those have RF value of 0.62 and 0.93, and then that literature will show, acha, okay, fine, that library, the library of these dyes of RF values will show me, acha, 0.62 is for rhodamine B, and whereas 0.935 is for fluorescent. Am I clear to everyone?
Yes, ma'am.
Acha, you don't want me to repeat it again, right?
No, ma'am.
Okay, good. So let us see a video of separation of dyes first, and then we'll go to see now the process, the procedure of spotting, the procedure of calculating, everything is same. It's just will change the solvent system, will change our analytes. The mixture will be different, and the mobile phase will be different. Otherwise everything, the procedure, the calculation, everything is same. How do we pre-saturate our solvent system, everything. so let us start with a video where, see here in this video we are not showing rhodamine B and fluorescent, it is some other dyes, but however you can see how the separation occurs. Because it is being colored, you can see it, you do not need any other standards, but still they use standards because that is an ideal way to know. तो अर्चना,
Separation of components from a mixture of red.
Is my screen visible now?
Yes, ma'am.
Yes, it is. Just make it full screen.
Actually, when I make full screen, then I'm having trouble. Uh, you know, is it fine?
Yeah, no problem. No problem, no problem. We can see it this way.
And blue inks by paper chromatography. Chromatography is one of the most important separation techniques and is extensively used to separate mixtures and their components. It was first employed by the Russian scientist Mikhail Svet. In the paper chromatographic technique, the mixture of substances is applied onto a Wattmann filter paper strip in what is called the stationary phase. A pure solvent or a mixture of solvents is allowed to move slowly over the stationary phase. This moving phase is called mobile phase. When a mobile phase is moved over the mixture on the stationary phase, the components of the mixture gradually are separated from one another. Our aim here is to separate the components from a mixture of red and blue inks by paper chromatography. Materials required: chromatographic chamber with lid, mixture of red and blue inks, isopropyl alcohol water mixture, Wattmann filter paper strip, fine capillary tube, thread, scale, and a pencil. Procedure: take a Wattmann filter paper strip and draw a line with a pencil above 2 centimeters from one end. Draw another line lengthwise from the center of the paper. Name the point at which the two lines intersect as P. Take the mixture of red and blue inks using a capillary tube. Put a drop of mixture of red and blue inks at the point P. Allow it to dry in open air. Put a
please pause the
drop on
video.
the spot to dry again so that the spot is.
देखो, you can see over here that the spot जो लगाया था, that has been spread. ठीक है, जब लगाया था initially, that was the spot was very small circle. However, with time it got spreaded. ठीक है, जब दूसरा spot लगाया तो it got more spreaded. Now the spot has been like a very big circle. So yes अर्चना, हाँ बस तू वहीं पे जाना फिर से. 27 seconds पे. Yes. So now you can see over here कि क्योंकि the spot was very large. No, that the spot was very large. That means it was highly concentrated. In that case, we can see over here प्रॉपर जैसे बैंड्स आना चाहिए. सी यहाँ पे देखो किस स्प्रेडेड वे में वो रन हो रहा है ऊपर को. आपको दिख रहा है जैसे ब्लू वाला देखते हैं तो ब्लू वाला भी स्पॉट आपको जो दिख रहा है यहाँ पे जो रन हुआ है, जो यहाँ पे वी कैन सी अ सेपरेशन बिटवीन रेड एंड ब्लू. हियर यू कैन सी कि वो कैसे खींचा जा रहा है. ब्लू ऊपर खींचा जा रहा है एक प्रॉपर वे में, एक बैंड शेप में नहीं है. बैंड यानी एक इधर जो सर्कल वे में डाला है तो सर्कल वे में ऊपर जाना चाहिए ना, या तो एक यू नो प्रॉपर वे में नहीं जा रहा है. यू कैन सी दैट, है ना. आपको दिख रहा है ना, आपको समझ में आ रहा है ना. स्टूडेंट्स हाँ
Yes, ma'am.
ठीक है. तो ये जो ब्लू कलर का आपको दिख रहा है तो कैसे वो पूरा स्प्रेडेड वे में ऊपर भी जा रहा है. So अब इस केस में क्या है, proper see TLC can also be used once the separation is done. We can also go for the concentration also to determine the concentration also. ठीक है. TLC you people are just going for a separation purpose. However, once we separate it, we can use that material and we can actually find out the concentration of the sample also. And for that, if this type of separation occurs, then proper concentration हमें जो चाहिए ना, that will not get because it has been spreaded. You may continue, Archana, now.
The components of the mixture gradually are separated from one another. Our aim here is to separate the components from a mixture of red and blue inks by paper chromatography. Materials required: chromatographic chamber with lid, mixture of red and blue inks, isopropyl alcohol water mixture, Whatman filter paper strip, fine capillary tube, thread, scale, and a pencil. Procedure: take a Whatman filter paper strip and draw a line with a pencil above 2 centimeters from one end. Draw another line lengthwise from the center of the paper. Name the point at which the two lines intersect as P. Take the mixture of red and blue inks using a capillary tube. Put a drop of mixture of red and blue inks at the point P. Allow it to dry in open air. Put another drop on the same spot and dry again so that the spot is rich with the mixture. Take a piece of thread and tie the filter paper to it. Suspend the filter paper vertically in the chromatographic chamber containing solvent, which is a mixture of isopropyl alcohol and distilled water. Make sure that the pencil remains about 1 centimeter above the solvent level. Keep the chamber undisturbed for some time. Notice the rising solvent along with the red and blue inks. After the solvent has risen, you will notice two different spots of blue and red colors on the filter paper. Take the filter paper out of the chamber and mark the distance that the solvent has risen on the paper with the pencil. This is called the solvent front. Dry the filter paper and put pencil marks on the center of the red and blue ink spots. Measure the distance of the two spots from the original line and the distance of the solvent from the original line. Calculate the RF values of red and blue inks by using the formula RF is equal to distance traveled by the component from the original line divided by distance traveled by the solvent from the original line. Precautions: always make use of a fine capillary tube. Keep the chamber undisturbed and covered during the experiment. The spot should be rich with the mixture.
Okay, Archana, can we just go to that scanned journal part for dyes itself? Just show me the RF value of dyes. Okay, fine. बस यही हाँ बस good fine. See now, can you people tell me by seeing this RF values ki which we have two molecules over here, that is rhodamine B and fluorescein. Can you please tell me which of these from the two components, which of the component have more affinity towards stationary phase, have more affinity towards the mobile phase, or lesser affinity towards mobile phase or stationary phase? Can we have a judgment by seeing these values? Can anyone tell me?
Rhodamine is more affinity towards the stationary phase.
Okay. तो मोबाइल फेस में उसका एफिनिटी नहीं है, आप ऐसा कहना चाहते हो?
No, ma'am.
Relative to fluorescence.
Okay. So fluorescents have what kind of affinities between fluorescent and stationary phase? what kind of affinity is between, is it more, high, good, bad, between fluorescent and stationary phase? अरे सवाल समझ में आया आप लोगों को? मेरा सवाल ये
Not
है कि जो, हाँ जी बोलिए। यस रोहन।
not high.
Not high. See, can I put it in this way? Fluorescent have very less affinity towards stationary phase, and it has very high affinity towards mobile phase, that it is going with the mobile phase, because the RF
Yes.
value is almost near to 1. RF value जो होता है वो 0 और 1 के बीच में ही रहता है, ठीक है? तो it is almost going with the run is almost with the mobile phase. So I can definitely conclude it that the fluorescent has very high affinity towards mobile phase. That means which almost moves with the mobile phase, whereas in rhodamine B case, the affinity towards mobile phase is moderate, right?
Yes, ma'am.
Yes,
Okay.
ma'am.
Now I believe that the TLC separation of dyes on TLC is very much clear to you, or you want me to explain anything? If not, we'll move
Ma'am,
ahead with the separation of drugs. Is everything clear to you?
मैम
हाँ जी।
मैम आपने वो प्री सैचुरेशन के बारे में कुछ बताया था, वो जरा एक बार रिपीट हो जाए।
हाँ, I'll do that. देखो, प्री सैचुरेशन चेंबर को सॉल्वेंट सिस्टम की सॉल्वेंट चेंबर, यू अंडरस्टैंड व्हाट इज सॉल्वेंट चेंबर? सॉल्वेंट चेंबर अपने एक बड़ा नाम दिया है, बट उसके अंदर क्या होता है? इधर चेंबर इज अ बिगर वन, एक ग्लास लिड होता है रेक्टेंगुलर शेप में, या तो फिर एक ग्लास बीकर होता है। बीकर तो देखे है ना, 250 ml के या 150 ml के बीकर। वी टेक दैट बीकर एंड वी क्लोज इट विथ अ वॉच ग्लास, ठीक है? So that is our solvent chamber. वो उसको हम chamber बोलते हैं. So in that case what we are doing is कि in this case we are taking acetone and water. You know every solvent has some, they vaporize, right? उनका evaporation रहता है after a certain period, like उनका vapor रहता ही है. So what we do is when we take our mobile phase into our chamber, so mobile phase chamber, तो what we do is अगर हम उसको बंद नहीं करते हैं तो क्या है? सॉल्वेंट जो भी मोबाइल फेस वी टेक, इट कंटिन्यूअसली वेपोराइजेस, क्योंकि वी हैव सम टेम्परेचर, वी हैव सम रूम टेम्परेचर also, so it continuously vaporizes. So we don't want that condition to arise, because if that happens then our TLC plate जब हम अंदर रखते हैं उसके अंदर मोबाइल चेंबर के अंदर, at that time अंदर सब प्रॉपर रन नहीं दिखेगा हमें। तो प्रॉपर रन हमें कब दिखेगा? व्हेन आवर चेंबर इज प्री सैचुरेटेड माने कि अंदर वो जो सॉल्वेंट चेंबर है उसके अंदर सिर्फ और सिर्फ मोबाइल फेस सिस्टम के ही मॉलिक्यूल्स या कंपोनेंट्स घूम रहे हैं। समझ में आ रहा है आप लोगों को? सिर्फ इधर इट मे बी इन गैसियस फॉर्म और इन द लिक्विड फॉर्म जो हमने डाला है। तो हमने क्या करना है? हम लोग प्री सैचुरेशन यानी वी आर प्री सैचुरेटिंग इट बाय कीपिंग इट फॉर 30 मिनट्स, सच दैट जो भी हमारा मोबाइल फेस है वो मोबाइल फेस हमने डाला, वो मोबाइल फेस को हमने बंद कर रखा। तो अब जब बंद करके रखा है तो उस पूरे एनवायरनमेंट में, मेरा एनवायरनमेंट का कहने का मतलब ये है कि उस बीकर के अंदर, इन दैट एनवायरनमेंट, द एनवायरनमेंट कंसिस्ट ऑफ ओनली द मोबाइल फेस मॉलिक्यूल्स, only the mobile phase molecules. It does not interact with anything. So when we place our TLC plate in that solvent system which has only mobile phase molecule, तो पूरे TLC plate पे the mobile phase molecules are interacting, ठीक है, along with our mixture. समझ में आया?
Yes, ma'am.
अगर हम उसको प्री सैचुरेट नहीं करते हैं तो सपोज ऊपर के पोर्शन में द अपर साइड ऑफ आर TLC प्लेट, सो इफ इट इज नॉट बीन प्री सैचुरेटेड तो जितना हमारा अगेंस्ट द ग्रेविटी जो हमारा सॉल्वेंट सिस्टम रन होएगा उतना ही, अदरवाइज अगर प्री सैचुरेट करके वी आर यूजिंग दैट TLC प्लेट टू रन, इन दैट केस हर जगह से सिर्फ और सिर्फ सॉल्वेंट मॉलिक्यूल्स ही इंटरेक्ट कर रहा है, मेरा कहने का मतलब वो है, ठीक है, क्लियर ना अब तो?
Yes, ma'am.
Okay, we shall now move ahead with the second practical for today's session, that is separation of drugs. So Archana, वो scanned journal दिखा दे यार. See now the TLC separation of drugs. We are using two drugs, that is domperidone and omeprazole. Domperidone is anti-dopaminergic, comes under that category. Omeprazole is an antacid. See, all other things are same. Everything is same. Here in DICE, it was we did not need any chamber or any detection visualization system. However, in this case, which is different from the DICE separation, we need a chamber to visualize. That we use here is iodine chamber. Now, our solvent system in this case is chloroform and methanol. Chloroform and methanol in the ratio of 9:1. That is 9 ml of chloroform and 1 ml of methanol. Everything is same. We will be preparing our sample, that is domperidone and omeprazole. Then we will be again spotting the samples in a similar manner with two standards and one mixture, everything same. It will have separation after a certain, we will be pre-saturating our solvent chamber, mobile phase chamber with our solvent system, mobile phase system, and then we will allow our TLC plate to have a run in that solvent system. Once the solvent, the mobile phase has reached a particular distance that has been marked, we'll take out that solvent, take out that plate. We will allow it to dry in the air dry. Once it gets dried, now in this particular case, the both domperidone and omeprazole both are colorless. Now the problem comes because it has been colorless. So separation ke baad we can just see a small spots or colorless spots. Once it dries, वो spots भी चला गया because that is colorless, पानी जैसा होता है, तो वो भी नहीं दिखेगा once it is being dried, right? Now, so now in this case, you understand why standards are very important, right? So once it is being dried, we take this TLC plate into an iodine chamber as a visualization chamber. Now this iodine chamber, how do we prepare iodine chamber? Either we can use an iodine solution and we can spray that iodine solution onto this TLC plate. Else what we do, that means जो आप लोगों को करना होता अगर आप आते तो, is we'll be making an iodine chamber by putting a few crystals of Ki, that is potassium iodide, into a beaker, plastic beaker, and then we will close it. After closing it, we'll just allow the iodine vapor to be in that beaker's environment, we can actually with our naked eye see there is an iodine vapor in that chamber. Then we will, once it is been, again we have to see, we have to pre-saturate, I mean we have to properly saturate that visualization chamber by placing the iodine crystals in that beaker, and we have to close it for at least 15 to 20 minutes so that iodine vapor is in that entire environment. And once it is being done, we will be taking that TLC plate and placing it into that visualization chamber, that is our iodine. We'll keep it for few minutes, that is 2 minutes is more than enough, like 1 minute is enough. We'll keep that, and then we can, I mean, you know, we'll keep the TLC plate in iodine chamber till we see the spots, a brownish, light brownish colored spots, till that is being seen, or that is being evident to you. Till that time you will keep the TLC plate in that chamber. It takes few seconds, like 60 to 850 60 to 75 seconds it takes. And then once the spots are very much visible, which is bright yellow, or I mean either it is yellow, I'll not say yellow, it is almost light brownish colored. Once it is being visible, we take that, we then measure, then we calculate the distance traveled by both, you know, domperidone and omeprazole in the similar manner that we have did in the case of dyes. Right? Now, iodine chamber. Why do we use iodine chamber? The first question is, why do we use iodine chamber? So, iodine chamber for visualization system for drugs is because iodine forms a complex with unsaturated or aromatic compounds. So that is the main reason that we here in this case use iodine chamber. We can also go for UV light. However, UV light for in our case is not feasible for us. So the easily available technique was iodine chamber. So we go for iodine chamber. So in tight closed environment, iodine vapor is there that interacts with our organic molecules. Those are domperidone and omeprazole. We get the spots, and thus we can calculate the distance traveled by the solute and the distance traveled by solvent. So this is very much easy, right? Nothing is like rocket science, kuch hai nahi, I guess. Am I clear?
Yes, ma'am.
Okay, then we can definitely go for the video of where we can see the separation of drugs is done. So let us request Archana to do that, to share the screen. In this case, analgesic drugs are being used here. यहाँ पे the separation of 4 to 5 drug components are being done. However, in our case, it's only 2 components that we separate with the standards. The procedure is almost same. You just have to see how the separation occurs. You just have to make sure ki where we should stop, how the measurement is done, what is the distance traveled by the solvent, how do we calculate that. Yes, even in the iodine chamber, I guess the iodine chamber, the brown spots has also been shown in this. Archana, please play the video.
The TLC analysis of analgesic drugs. It will go through the procedure as well as data and observations. A reference plate and sample plate were each made and analyzed. The procedure is shown on figures 1 through 7 and 10 for the reference plate and figure 8 for the sample plate. Many of the procedural steps on the reference plate and sample plate are shown here and throughout other slides. To start, a TLC plate was used and a line was drawn with a pencil 1 centimeter from the bottom of the plate. On the 1 centimeter line, 6 small dash marks were made and numbered 1 through 6. Above are the 6 solutions that are used on the reference plate. Notice that a wooden pencil is used for this, not a mechanical pencil or a pen. This video is showing the spotting technique used with the reference plate. A capillary tube was used. It is a small tube that is open on both ends. It is dipped into the solution and then lightly touched onto the TLC plate where the dash mark meets that 1 centimeter line. The solvent is allowed to evaporate, and then the solution is spotted one more time to make sure that enough of the active ingredient is present on the TLC plate. Figure 4 shows the reference TLC plate after it has been spotted. Figure 5 shows the developing chamber and developing solutions that were used. Developing chamber was just a large beaker, and the developing solution is 0.5% glacial acetic acid in ethyl acetate. The developing solution was poured into the developing chamber, so only about half a centimeter deep was used. Figure 6 shows the reference TLC plate in the developing chamber. A recrystallizing dish was used as a lid. There's an arrow pointing out the current solvent level. It is about 1/3 of the way up the plate. The TLC plate was removed when the solvent was about 1 centimeter from the top. Figure 7 shows the plate after it was removed. After it was removed, a pencil was used to draw the line where the solvent reached, and then the solvent was allowed to evaporate. The same procedure was used for the sample plate. A TLC plate was obtained, a line was drawn with a pencil 1 centimeter from the bottom. These 4 analgesic drug solutions were spotted on the dash marks on that 1 centimeter line. The plate was developed in 0.5% glacial acetic acid and ethyl acetate and was removed from the developing solution when the solvent was approximately 1 centimeter from the top. In order to view the data, 2 methods were used. First, the plates were observed under UV light. This is the reference plate under UV light. Second, the TLC plates were placed in a jar containing iodine crystals under very low heat. Figure 11 shows the reference TLC plate after it was removed from the iodine jar.
Archana,
Figure 12.
please pause. Yeah, fine, thanks. So you might have seen that how the spots looks like in iodine chamber, right? Can we have the look at? Yeah, great. Fine. See here you can see how the spots look like. Those are like brown, dark. I mean not dark brown, but however that the cursor where we, yeah, fine. The cursor now where we see is the spots which are almost brown in color. We can see how the spots are separated, that those are brown in color. It is an iodine chamber. You have seen the iodine. Just we can go back to few, we can just go back in this video where the iodine jar is shown. Oh great, yes. Yeah, see in this way only we actually we do have an iodine chamber in our lab also, the similar pattern, but this is almost a jar, a bottle type say. But in our case we have a beaker in that we place few crystals of iodine Ki, and then we allowed to get that saturated, and then once the separation or run is complete, we place our TLC plate in that iodine chamber, and then we again close it with the lid. जैसे कि almost same है, but this is just a jar. यहाँ पे जो jar का जो है portion है, जो glass का है, that in our case we use beaker. The lid जो यहाँ पे जो bottle को बंद किया है, in our case we use watch glass or petri dish. Right, it is almost same, and you can see how the separation ऐसे ही दिखता है. The TLC plate looks like this when we place it in iodine chamber. Clear? समझ में आ रहा है आप लोगों को? यहाँ पे देखो we have बहुत सारे spots यहाँ पे नीचे, कुछ spots we can see just जो just they haven't even no ऊपर गया ही नहीं है, काफी सारे spots तो we can see here, but in our case we get a proper separation. तो अर्चना जहाँ से हमने बंद किया था वहीं से स्टार्ट कर दे यार. यहाँ पे देखो UV chamber है, UV chamber में अलग दिखता है, but when we take out from the UV chamber, the spots will not be visible. In UV chamber, what happens is when we keep our TLC plate in UV chamber and we put on the UV light, at that time the spots are visible. So in that case, what we have to do is we have to place there will be a direct contact of UV light with our hand, because we have to take our hand inside the UV chamber and we have to circle out the spots that we see in UV light. So that is bit harmful. You know how UV light is harmful for our hands. So a better thing is to have an iodine chamber, which is very much comparatively it is not that harmful. No, yes, we may continue with our video now.
I guess that's it about this.
Okay, acha, we are done with that video, right?
Yes.
Okay, so can we have a look at scanned journal again?
Yes, sure. Please hold on.
Yes. So students, I hope this was clear to you. We have tried to explain each and every points that was possible for us to explain it to you. Like I don't think so we have missed any points. However, if you have any doubts, please you can ask. You may ask. Oh yes. Let's can we see RF value of domperidone and omeprazole? Okay. See, again, this have moderate polarity, moderate interaction between both mobile phase system and stationary phase. Omeprazole. Oh yes, it has more affinity towards mobile phase than stationary phase, right? From these values, we can conclude that. है ना? Students, can we have some response from your side?
Yes, ma'am.
Okay, तो आप लोगों को पता चला ये वाला practical?
Yes, ma'am.
Okay.
Say
So
something.
with your permission, हाँ ये अर्चना.
Did you say something?
No,
Did you say
nothing,
something to
nothing
me?
at all. Nothing at all. So, Archana, we may go to the next practical, that is separation of amino acids by TLC. We can.
Should I open the journal?
Yes.
Oh.
Okay, so for today's session, our last practical for discussion is TLC separation of amino acids. The amino acids are L-valine and L-tryptophan. Here we use visualization chamber as anhydrine. The solvent system is butanol, acetic acid, water. It is a, we have three solvent in our solvent in our mobile phase. So before I start, L-valine and L-tryptophan. So here capital L, what does that indicate? चलो बताओ.
Levo,
Students. Yes. Somebody was saying something. Yes.
levo, dextro, levo. Me L2.
Dextrolivo. Tell me what is dextrolivo then? Here capital L indicates what? Somebody told me it is dextro and levo. It denotes levo rotatory, right? So does anyone have any other answer other than this?
The polarized light is polarized by that it means it is L denoted.
Sorry, I cannot hear you. I didn't hear you, Devashi. Can you
Uh,
please repeat it again?
okay, in polarimeter,
Mm-hmm.
where we put particularly amino acids,
Mm-hmm.
they polarize them. What I say? If a polarized light parallel and the compound is what a kind, it turn light left. It means it is
Okay, that means
levorotatory.
you are just talking about dextro-rotatory and levo-rotatory, right? The same thing?
Yes.
In polarized light, when molecule is being subjected to polarized light, uh, the dextro-rotatory and levo-rotatory जो होता है, you are talking about the same thing, right?
Yes, ma'am.
Okay, let me tell you, it is not that. वो जो dextro-levo-rotatory, that has been denoted by small d and small l, not capital D and capital L.
Ma'am,
Capital D.
sorry.
OH group
Right.
hydroxides.
Again, हाँ, चलो बताइए क्या है? हाँ, Nikhil, you have raised your hand. You wanted to share
Ma'am, I
something?
think in capital L and D, we are measuring that last carbon having a OH in left side or a right side is denoted by capital L and capital D.
Yes, you're absolutely right. So in this case, OH is on left side, so it is being denoted by capital L, which is L-valine and L-tryptophan. So yes, so these both are amino acids. All the procedure is same as that has been discussed earlier in the dissection. Everything is same. Mm, Archana, I guess the screen went off. So yes, L-tryptophan and
Did it come back?
No, I cannot see. I cannot see the screen.
Okay, let me just type.
No problem. See, both L-valine and L-tryptophan are amino acids. Again, amino acids, this will be dissolved, this will be solubilized in the particular solvent. Yes, it is visible now, Archana, it is visible. So both tryptophan and L-valine will be dissolved in particular solvents. Then again, the spotting is done the similar way that we saw in earlier case. Then we make a solvent chamber. Pehle what we do is we make a mobile phase chamber, that is solvent system chamber. solvent chamber by adding butanol, acetic acid and water in the ratio of 4:1:1. That is 4 ml of butanol, 1 ml of acetic acid and 1 ml of water. We add that, we keep it for pre-saturation of solvent system. Once it is done, we meanwhile we do all the spotting thing on the TLC plate. Once it is done, we place our TLC plate in the solvent system. We allow it to run. Once it is even that is done, we take out our TLC plate, we allow it to dry. Now in this case we use ninhydrin as a visualization chamber. In this case we use visualization chamber as, in this case our visualization chamber is ninhydrin. Now what is ninhydrin? Why are we using here ninhydrin? The ninhydrin here forms, reacts with the amino group which is present in this amino acids. The amino group which is present in amino acids, that NH3, the NH3 group which is present in amino acids will react with ninhydrin and it gives a reduced product which is diketohydrin. We get when in this case, after spotting, after it has been dried, we take out the TLC plate, we allow it to air dry. Once it has been air dried, we dip our TLC plate into the ninhydrin solution. See, there are different methods to do that. We can actually give a ninhydrin spray also. However, in our lab, what we do is we actually use a ninhydrin solvent, a solution which is prepared in RS, that is rectified spirit. We use that we use that ninhydrin solution. We pour that ninhydrin solution into a petri dish, and what we do is the dried TLC plate is being taken. We dip that dried TLC plate into ninhydrin solution such that the whole plate is being immersed into the ninhydrin solution, and then we take out that ninhydrin solution, take out that plate from the ninhydrin solution. We allow it to dry in oven at particular temperature of 105 degrees Celsius. Once it has been dried, we can see the blue spots, separated blue spots of both, the standards, we already have that, the blue spots of standards can be seen, and the separated blue spots can also be seen in that plate. So what actually happens is, why do we get these blue spots? The reason of blue spots is that the amino group which is present in the amino acids react with the ninhydrin molecule, react with the ninhydrin to give a diketohydrin, which is blue colored substance. And when that blue color is seen, blue colored mixture is, separated mixture is seen, at that time we can know that there is an interaction between the amine group, that is NH3 group of amino acids, with ninhydrin molecule. Fine. So let me give you an what happens is, generally when we dip our ATLC plate into this ninhydrin solution, sometimes there is the solution comes in contact with our fingers also. At that time, within a few minutes, we can see even our fingers are being blue colored. The fingers gets blue colored. The where ninhydrin has been contacted with our hands, at that the places where there is a contact between ninhydrin solution, or all those places get blue colored. Now I want you to answer me why that blue color comes. Does anyone know that? बच्चे लोग कुछ समझ में आया?
क्वेश्चन रिपीट करो ना मैम.
Okay. Did you understand the practical? I mean, did you understand what all I have discussed with you right now?
Yes, ma'am.
Acha, you
Yes,
you
ma'am.
have not followed the question. That's the only case, right?
Yes.
Okay, fine. Let me repeat the question for you. See, when we dip our TLC plate, जब हम dip करते हैं TLC plate in our ninhydrin solution, आप समझ रहे हो ना? We have a petri dish. Petri dish के अंदर what we do is we make a ninhydrin solution, and that ninhydrin solution is poured into that petri dish. Petri dish is full of ninhydrin solution. Now, when we take our TLC plate and when we dip our TLC plate into that ninhydrin solution, sometimes, not sometimes, most of the times, it has been seen that our either index finger or thumb comes in contact with our comes in contact with the ninhydrin solution. As soon as it comes in contact with the ninhydrin solution, within few minutes we can see that the places where our finger has been come in contact with a ninhydrin solution is being colored blue. We can see blue colored in our hands or in fingers. So why this blue color is being seen in our fingers?
मैम क्योंकि हमारे
Ma'am,
फिंगर
because
टिप्स में
presence
भी
of
हम
ammonia or NH2.
Okay, Devarshi, let us give chance to the one who was speaking before you. Then you can speak. So please, कौन बोल रहा था पहले वो please बोलिए.
यस मैम
हाँ.
क्योंकि मैम हमारे फिंगर के टिप्स में भी प्रोटीन या अमीनो एसिड प्रेजेंट है.
Okay, अच्छा. Devarshi, what's your call on this?
Almost same, ma'am, because ninhydrin test is usually performed for amino acids to detect it. Fingertips also have proteins and amino acid. Due to in the presence of this, ninhydrin solution give colored to our fingers.
Okay, you people are absolutely right. In our body also we have amino acids. You know about 20 amino acids are there, different types of amino acids. So yes, you people are right. Because when our body has, the finger also has. So when it comes in contact with ninhydrin, the main group of amino acids in our finger also reacts with the with the ninhydrin solution. So it gets blue in color. Is it clear?
Yes, ma'am.
Okay, now let us quickly go to the video of this amino acid separation. I guess everything else has been explained. There is nothing much left. It's almost same that we have been seeing in the previous two practical. So let us quickly go to the video.
Anarga, just hold on. I'm working on it.
Yeah, no problem. So meanwhile, students, is everything clear to you? Do you find any difficulty or any problem with the practicals that has been discussed today?
No, ma'am.
Is everything clear what TLC is? I mean, you will have a brief discussion about what TLC is. You will learn, you will dig into it because you have a unit exclusively in your syllabus, chromatography. However, the TLC part, which you might have, which is there in your practical session, I guess it is very much clear to you. So we have the video over here. Archana, is there any problem?
Is the audio clear of the video?
No, there's no audio actually.
Wait, just hold on.
Yeah.
Thin layer chromatography, TLC, is a method used for rapid qualitative analysis, where components in a mixture can be separated and identified. This video is focused on the general method.
Is it fine now? Were you able to hear?
Yes, ma'am.
Yes, ma'am.
Or procedures used in TLC. And for information on the theory, you can check your lab manual or lab guide. Separation occurs on a thin layer of silica on top of a solid support, such as a sheet of glass or a sheet of plastic as seen here. And this is called the TLC plate. The properties of the silica and the properties of a solvent are used to draw the components up the plate. Differences in the properties of the components in the mixture mean that each component will travel up the plate at a different rate, and this causes a separation. The separated components can be identified by comparing how far they travel along the plate relative to reference material, also known as standards. Let's take a closer look. First of all, we need to prepare the TLC plate. Make sure that you handle it only by its edges or use tweezers since we don't want to contaminate the silica gel surface. A ruler is used to draw a line using a pencil about 1 centimeter from the bottom edge of the plate. And draw only a very light line and try not to score the surface of the silica. This line is called the origin. Vertical markers are spaced about 1 centimeter apart along the origin. These markers are used as points of reference when applying mixtures and standards dissolved in a suitable solvent. And here we are going to run 4 lanes, lane A, B, C and D. In this demonstration we are going to see how to separate and identify using TLC. In this bottle the identity of the contents is unknown, but we do know that it contains either compound X or compound Y, or even a mixture of both. In this bottle we have an authentic sample of compound X, a sample which we know beyond any doubt is compound X, so we call it standard X. This is our first reference. In this bottle we have an authentic sample of compound Y.
Hello students, I had some internet issues. Am I audible to everyone?
Yes, ma'am.
Okay, fine. What about the video? Archana, are you there? Archana? Is Archana not there in the meet? Oh, Archana, what happened? Is there any problem? I got some internet issues
Yes,
and I was
there was. I think yes, there was. Let me just. Yes, I ran into a problem. I just try to.
मैं दिखा दूं क्या? अर्चना मैं दिखा दूं? मेरे को मिल गया। अच्छा ओके।
Separation of amino acids by TLC. Amino acids are the building blocks of peptides and proteins. They possess two functional groups, the carboxylic acid group that is the character and the
Archana, I guess there is some internet issues. Students, sorry for the inconvenience. Shall I share my screen from here? If it is, I don't know whether I don't know will it be uh, you know will the internet allow us to see the video or not? But let me try from here. What's say, Archana? Mm. Okay, students, let me try from here. Mm. We are really sorry for the inconvenience that you are facing right now, but we are trying our best. Okay, I guess my screen is visible to you.
Yes, ma'am.
Okay, fine. Just confirm the audio is audible to you. Was the audio audible
Yes,
to you?
ma'am.
Okay, fine.
separation of amino acids by TLC. Amino acids are the building blocks of peptides and proteins. They possess two functional groups, the carboxylic acid group that gives the acidic character and the amino group that provides the basic character. The properties provided by these groups are used to characterize the amino acids. Here, TLC or thin layer chromatography can be utilized to identify the different amino acids. Separation occurs as each component, being different in chemical and physical composition, interacts with the stationary and mobile phases to a different degree, creating the individual spots on the plate. Here, our aim is to identify an unknown amino acid by spotting it along with the known amino acids. Apparatus: TLC plate, solvent, a mixture of N-butanol, acetic acid, and distilled water in the ratio 12:3:5, 3 known amino acids, an unknown mixture of amino acids, ninhydrin, a spray bottle, a blow dryer. Developing a TLC plate requires a developing chamber or vessel called TLC chamber. This can be as simple as a white mouth jar. The chamber should contain enough solvent to just...
See, here in this case, they are using a spray chamber. I mean, they're spraying ninhydrin. But in our case, I just earlier told you in that way only we will be using a petri dish. In petri dish, we will be pouring the ninhydrin solution, and into that we will be dipping our TLC plate. Okay, let's continue.
just cover the bottom. It should also contain a piece of filter paper or other absorbent material to saturate the atmosphere with solvent papers. Finally, it should have a lid or other covering to minimize evaporation. Procedure: cut the plate to the correct size and using a pencil, gently draw a straight line across the plate approximately 1 cm from the bottom. Using a capillary tube, a minute drop of amino acid is spotted on the line. Allow the spot to dry. Spot the second amino acid on the plate. Repeat the steps to spot the unknown. Place the plate into the TLC chamber as evenly as possible and lean it against the side. Allow capillary action to draw the solvent up the plate until it is approximately 1 cm from the end. Remove the plate and immediately draw a line across the solvent front. Dry the plate with the aid of a blow dryer. Spray the dry plate with ninhydrin reagent. Dry the plates in hot air oven at 105 degrees Celsius for 5 minutes. Here, ninhydrin will react with the spotted amino acids and the resulting complex, which is colored, makes them visible on the plate. After some time, mark the center of the spots, then measure the distance of the center of the spots from the origin and calculate the RF values. Some tips for a successful result. Make certain that the spots applied to the plate are above the surface of the eluting solvent. Hold the plates by their sides. The solvent front must not advance up to or beyond the edges of the plates.
So was that, did you follow that video? I mean, did you understand what the video was trying to say and how your practical was related to it? Students.
Yes.
Yes, ma'am.
Okay. So with this we have completed all the three practical sessions that we were supposed to complete for the day. We have one more video which will brief you about thin layer chromatography. So I just want you people to see that because you're not performing the practical, so it will be more clear to you how do we use it, thin layer chromatography, and what are the other factors affecting, or what we should keep in mind while performing the practical. So with your permission, with your permission, do you want me to play that video? Students?
Ma'am, if you could share that link to us.
Yes, I
Later.
will. Okay, fine. I'll do that. So, Archana, are we missing anything in today's practical? Are we done with everything? I mean, have we covered everything? If I am just missing anything, Joe, so you could please add to it.
I guess not. I think we have almost covered everything related.
Okay. So, students, is everything fine with you with these three practicals?
Yes, ma'am.
ओके ऑल डन. क्या हुआ रिचा? यस मैम, मतलब क्या हो गया? बहुत बोर हो गए हो, ऐसा कुछ है?
मैं यही
नहीं
पूछने
नहीं
वाली थी कि ऐसे रोते
नहीं,
रोते
मतलब मैं ऐसे मतलब लाइक आई एम सिटिंग इन द वे, लाइक वो आवाज ऐसे निकल रही है इसलिए, और कुछ नहीं.
अच्छा, ओके. सो इज एवरीवन लाइक सैचुरेटेड? आप लोगों का प्री
वन हैंड इज
सैचुरेशन हो
रेज
चुका है,
अनल्ट्रा.
ऐसा कुछ है?
वन हैंड इज रेज.
हाँ, यस निखिल प्लीज.
Ma'am, according to your explanation, everything is good, but can you explain which type of questions are rise in Viva types?
See that you will be asked what is L-valine and L-tryptophan. It comes under which category? What is the polarity? Whether it is polar, non-polar. The other questions are, why are we using ninhydrin? What is the role of iodine chamber? Why can't we visualize it in any other chamber, or can't we use UV chamber? Then the categories of the drugs being under study, that is domperidone and omeprazole. Which category they comes under? Then what all? What is, why it is showing blue colored, when it reacts with amino acid, ninhydrin and amino acid reacts, why do we get blue colored spots? What is the reaction between iodine and the drug molecules? Why iodine reacts with the drug molecules? The basics of TLC, stationary phase is polar, non-polar. What is the composition of stationary phase? Based on what we use a solvent system, mobile phase system. How do we prepare solvent system? The RF value, yes, the RF value. How RF value, I mean, you have seen in many cases the RF value is very much low. So in this case, Archana, mera khula nahi hai scanned journal. So could you please share that scanned journal, or you want me to share that?
Yeah, sure, I'll do that.
हाँ प्लीज. तो ये लास्ट वाला प्रैक्टिकल निकालना ना यार, ये अमीनो एसिड्स वाला RF वैल्यू वाला. सो the RF value, why are we getting the RF value very much high or very much low? What is the reason behind that? What is the interaction between the analyte molecules and both stationary and mobile phase molecules? What else we have in our questions? Yes, the other question, this is a simple question.
Principle of chromatography.
Yes, it is. Yes, it is visible.
And
yes, it is. Just show me the RF value.
other than TLC.
Just show me the RF value. So in this case, you can see the RF value is very much low, which indicates that it has more affinity towards the stationary phase than the mobile phase. See, in this case, you can see that it has more affinity. The RF values are very much low. That means it has more affinity towards the stationary phase. Then why is it necessary to pre-saturate our solvent chamber? What does RF value range tells us? What is polarity? How polarity plays a very big role in separation of mixtures. So chromatography principles, types of chromatography. These are something which is for chromatography and types of chromatography, basics of chromatography, on what principles separation occurs. These are the questions that is purely theoretical, which has been asked in this Viva questions. Types of chromatography, what is adsorption chromatography, what is partition chromatography, what is ion exchange chromatography, why polarity plays a role in the separation of the mixtures, how polarity and electronegativity are related to each other. Then values of electronegativity values that indicates how polar the molecule is. फिर yes, मेन तो TLC का आपको A to Z पता होना चाहिए. I mean chromatography का A to Z पता होना चाहिए, because you've been dealing with TLC. However, you should know how paper chromatography works. What type of chromatography is paper chromatography? Is it solid liquid, or liquid gas liquid? ये सब भी you should know. What type of stationary phase are being used in liquid chromatography? Give examples of liquid chromatography. Am I going very fast? Because ये सारी चीजें एकदम से मेरे को दिमाग में आ रही है, तो मैं ऐसे just बता रही हूँ आप लोगों को. I hope you people are noting it down. Nikhil,
yes ma'am, ठीक है. According to you say that we are just only मीन्स हमें सिर्फ ऐसे बेसिक ही सब कुछ याद करें, क्योंकि इसमें पर्टिकुलरली ड्रग्स लेके हमें प्रैक्टिकल्स किए हुए हैं. तो अकॉर्डिंग टू वी आर नॉट परफॉर्मिंग एनी प्रैक्टिकल्स. तो हमें यही प्रैक्टिकल्स मीन्स कि यही रिएजेंट्स के साथ प्रिपरेशन करनी है, क्योंकि अलग दूसरा कोई रिएजेंट्स या कोई ड्रग्स होगा तो डाई होगा.
देखो प्रैक्टिकल में ये आपको नहीं पूछा जाएगा कि आप बताओ कितने ml आपने ब्यूटानॉल डाला आपके सॉल्वेंट सिस्टम में, कितना ml वाटर डाला, ये सारी चीजें नहीं पूछा
नो
जाएगा।
नो नो मैम, मेरा कहना ऐसा है कि जैसे कलर्स डाइस के अलग अलग कलर्स होते हैं हमें, तो पर्टिकुलरली आपने बताया था कि इसका ब्लू कलर आता है, इसका ये कलर आता है,
नहीं
तो
देखो हमने जो प्रैक्टिकल नहीं लिसन 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 निकल यू आर आई गेस मिसअंडरस्टूड। हमने जो प्रैक्टिकल किया है, इन दैट practical we are using rhodamine B which is red in color and fluorescent which is yellow in color, there is no blue color, so you will be asked questions about rhodamine B and fluorescent only। ऐसा नहीं कोई ब्लू कलर का मिथिलीन ब्लू या कोई और नहीं पूछा जाएगा, आपको पूछा जाएगा अबाउट टू ड्रग्स दैट इज domperidone and omeprazole। You will be
ओके
asked two
मैम,
amino
यस
acids।
यस, यही कंफ्यूजन था मेरा कि
हाँ,
यही
you will be
हमने क्या
asked about two
कंफ्यूज
amino
था।
acids, but ठीक है ये पता होना चाहिए कि amino acids है तो L valine है तो why L is there, what does capital L denote, domperidone you performed with domperidone and omeprazole, so under which category those dyes comes under, rhodamine B and fluorescent you should know what is the structure, what are the functional groups present in those molecules, these things you should know, you should know everything about the practical you have been you have been performing or you have been taught, you know, you need not know the other dyes that can be performed with these solvent system, no need of that।
ओके मैम, थैंक यू मैम।
Basic majorly you should know you should know proper concepts of chromatography should be known to you because that is very much important, how because you are performing chromatography, you don't need not worry about other things because you have exclusively a unit which is chromatography, everything is properly will be taught to you, so the things that we have missed out here because this is a practical session and so we cannot cover whole chromatography thing, we cannot cover each and every aspects of chromatography, however those things will be taught to you in viva, so you can link with that, right?
ओके मैम।
Okay, so is there any other student who wanted to ask something or any other, you have any other doubt about the practicals that has been discussed today, or any other doubts you have, if at all you may raise, you may ask us.
Can I say something?
Yes, Khushbu, please.
Ma'am, I just want to ask that how many maximum compounds we can separate using TLC at a time? I mean, 3, 4, or maybe more than that.
Yes, we can, there are many, large number of, at a time, large number of like 15, 20, 15, 15, 20 can be separated in one go by optimizing a proper solvent system, because there should not be no tailing, no fronting. You will know what tailing fronting is in your theory classes, but with that like 15 to 20 we can go in one go.
Okay, ma'am.
Yes, is there any questions from your side? So I believe you don't have any questions, then we shall wind it up. Yes, Archana?
You just gave a list of questions.
I cannot hear you, Archana.
So,
अर्चना तू, मेरे को सुनाई नहीं दी, तूने क्या बोला?
आवाज नहीं आ रही?
अब आ रही है, अब बोल।
हाँ, मैं ये बोल रही थी कि आपने ये कंप्लीट लिस्ट दिया है इनको, काफी सारे क्वेश्चंस आपने कवर किए हैं जो वाइवा में पूछे जा सकते हैं. So I just wanted to add, tell students that asking for Viva questions and all this is fine. Like we would definitely like to let you know what kind of questions are asked and do prepare this. But apart from this, I want to remind you that आपका जो एग्जाम होता है प्रैक्टिकल इंटरनल या एक्सटर्नल जो भी जब भी ये कंडक्ट करते हैं, every professor has got his or her own style of asking questions. This is just something, this is just like a path we can show you. इसमें हम टोटली आपको स्पून फीड नहीं कर पाएंगे। अब इतना आपको आइडिया आ गया है कि ऐसे ऐसे क्वेश्चंस पूछे जा सकते हैं, तो नाउ यू विल हैव टू टेक इट फॉरवर्ड, यू विल हैव टू टेक इट फर्दर। आपको बैठ के थोड़ा रेफर एंड रिसर्च करना ही पड़ेगा फॉर एवरी प्रैक्टिकल, not for not only for this one, because you might have some question which we did not discuss over here right now. ऐसा भी हो सकता है because every professor has got a different style. So uh, once you go through the practical, make sure that you look deeper into it and you look into various backgrounds. जैसे लास्ट टाइम बोला था ईडीटीए में उस बारे में ज़्यादा पढ़ना, अब यहाँ पे क्रोमेटोग्राफी और आपका तो यूनिट भी है इस बार, तो आपको थोड़ा और डिटेल में पढ़ना रहेगा कि सारे टर्म्स जो आते हैं, क्योंकि ये रिलेट करके आसानी से क्वेश्चंस प्रोफेसर्स पूछेंगे ही, बिकॉज यू आर हैविंग इन थियोरी ऑल्सो. So don't rely just on the questions that we are discussing. We are discussing it from our point of view. You have to take it further also. That was it, Anarga.
Yes, जैसे Archana just reminded me terms like capacity factor, resolution factor, dead volume, dead time. These are something which you will be you will be knowing it once you start with the chromatography unit. But these are some terms that some faculties, some professors come up with the questions. Yeah, that's it from our end. I guess everything is fine with us, so we shall now wind it up over here. So, students, is that fine? Shall we leave and we then meet on Wednesday, coming Wednesday?
Yes, ma'am.
Okay, fine. Then you may leave now. Thank you. आठ लोग बाकी है, मैं निकाल दूँ, मतलब मैं लीव कर दूँ, मतलब स्टॉप एंड मीटिंग कर देती हूँ.
हाँ कर दो, आप एंड मीटिंग कर दो.
हाँ, पहले रिकॉर्डिंग कर देती हूँ.